Hey guys, we're going to talk about how to solve equations with radicals. This is part 2 of this video. So we're going to be looking specifically at the situation where you have two square roots. So it's equations that look like this or like this. So notice that I've got two square roots. Okay, so just starting off with an example here. So I want to just kind of tell you the ground rules. What you want is actually what I have set up already. You want one radical isolated to each side. After you've done that, then you can just square. So if I do that on this example here, so I'm going to go ahead and, like I said, I've already got this set up, right? So I have one radical on each side. So if I square each side, this is actually going to be pretty simple because the radical goes away, so then I'm just left with 5x plus 2 equals 3x plus 6, and now you just solve as usual. So to solve, so I'm going to subtract off the 3x, and I'll subtract off the 2, so I get 2x equals 4, and then divide both sides by 2 to get x equals 2. Now, if you watched part 1 of my videos, you know that you do actually need to check your solutions. Sometimes you can have what are known as extraneous solutions. These are solutions that don't work, and it's not always obvious that they don't work. So let me do a really quick check on the side. So both sides are equal, so this all works out, so we're good to go. So that's just the really quick check that you want to do. So in these cases, these are kind of simple problems because you just have the one radical. So I want you to pause the video and try these and hit play when you're ready. So the next example is very similar to what I opened up with. So if I just square each side, so I get 3 minus 2x equals 2x plus 7. So let's see, I'll go ahead and I'll add 2x over to this side, and then I'll subtract 7 over from here. So then I get 4x equals negative 4, and if I divide both sides by 4, I get x equals negative 1. And once again, I just want to do a real quick check over here. And once again, this works out, so we're good to go with this one. All right. So same thing here. I'll start off by squaring both sides. So I get 5 plus 3x equals 3 plus 2x. Okay, so let me go ahead and solve for x. So I get x equals negative 2. So now let's check it. Okay, so as far as whether this actually works as a solution, this is a little bit dependent on whether or not you have imaginary numbers in your course. So if you're a student in my class, so if you're in just the standard class that we teach at my school, at this point in time, we don't have imaginary numbers. So if you don't know what imaginary numbers are, then you probably don't have them yet in your class. So if this happens, you would actually have to say then that this doesn't work because it makes your square root negative. So this would be kind of no solution at this time. If you are someplace where imaginary numbers exist and that this is okay, then you would have this. So it kind of, this is a little bit of a gray area, I guess, in some ways, just because it just depends on kind of what you're allowed to interpret here, but that could be one kind of pitfall. Okay, so for this next one, so this one's actually finally where we get a little bit trickier here. So remember, when you square, so I'm going to use this green color here to highlight this. So when I square both sides, so now notice I'm not just squaring this radical, but I also have to square this number. So just to make this nice and clear what this actually means, I have to square both the 4 and then this 3 minus 2x. So that's what I have to do. So then this becomes 16 times 3 minus 2x, and this side becomes 4 times 1 plus 3x. So notice how I squared just the number right in front, so that's very important. So now from here, though, you're going to solve as usual. So I get that x equals 1, so once again, let's just do a quick check over here. And so this does indeed work out, so this solution works. So I have just one more of these that I want you to try if that was, you know, just something different to you. So again, same technique, just square both sides, and then we're going to switch topics here. So let me go ahead and square both sides. So again, it's going to be that same thing. So this becomes 36x equals 16 times 2x plus 1. So then I get 36x equals 32x plus 16. So I'll go ahead and I'll solve this. So I get x equals 4. So let's just do a real quick check. And so you'll get here that you've got 12 equals 12, so we're all good here. Okay, so that's kind of the simple case of this. This does get harder if I switch it up just slightly. So what makes this example different from the other ones that I was looking at? Well, now I have this number on the outside, right? So this is going to actually make this a bit harder and just take a bit longer to solve. So first things first, so you do want to square both sides, but when you square, you are going to have to FOIL this time. So I'm squaring all of this and then just this side. So notice the difference here. So when you square, you're always squaring the entirety of a side, and so then you just have to kind of see what happens. And in this case, what will happen if I square this is then I actually have to work all of this out. So what I mean is I have to do this square root of 4x plus 1 minus 2 times this square root of 4x plus 1 minus 2. So I have to do that on that side, and then on this side I'll just have 2x plus 1. Okay, so now we've got to actually FOIL all this good stuff out. So I'm going to try to make this nice and clear. So when I multiply the root by itself, so that is actually going to cancel out the root in this case, so that's just going to leave me with 4x plus 1. Then when I multiply the root times negative 2, this becomes negative 2 times 4x plus 1. And I'll do that one more time here. So this once again becomes negative 2 times the square root of 4x plus 1. And then finally, I multiply those negative 2's together. This becomes plus 4. And all of this, don't forget your equal sign. We're trying to solve an equation here. All of this still equals the right side. So notice all this work I had to do on this side. So now what I need to do is actually just finish collecting my like terms and simplifying all of this. So as you look across on this, you have these two here are like radicals. You've got this 4x, and then you have this 1 and this 4. So think about what you can actually group up here. So I've got, this is really going to become 4x plus 5 minus 4 times the square root of 4x plus 1 equals, and I did nothing to the right side. So make sure that you actually believe this before you go on with this video, okay? This is a pretty key side to understand. The next thing that we're going to do then is we're actually going to work on isolating this radical. So what that means in this case then is I'm going to subtract off the 4x and the 5. Now this negative 4 here, this is attached to the radical. This can't go anywhere. We can't get rid of this, so this is just going to come along for the ride. But these two pieces here, these can totally go over to the other side. So now what I get is negative 4 times the square root of 4x plus 1 equals negative 2x minus 4. Now, notice when you look across here, do you notice anything that they have, these terms now have in common? One thing that you can do at this step, you can divide by the common factor if you'd like, and a lot of times that actually makes the problem easier. So if there is a common factor between the terms, divide by it. So in this case, I'm going to divide everything by negative 2 because it's just going to make my life easier. So now this gives me 2 times the square root of 4x plus 1 equals x plus 2. All right, so this is a whole lot of work we've done so far, and now we can kind of keep going with this. So let me clear off some space and we'll pick up from this line here. So make sure if you are taking notes on this, which I highly recommend for this that you do, I would actually write all of this detail out so that you have a better chance of understanding it. So pause the video if you need to just to write anything down. Okay, so now that I'm here, this actually boils down to just what we would do if we had just one radical in the problem. So now I want to square both sides again. So let's go ahead and do that. So I'm going to square all of this, and I'm going to square all of this, and you can see here that on this side, this is where you're going to have to FOIL. Now this side we just talked about at the beginning of this video, so this will be 4 times 4x plus 1, and then this, so I'll have to actually work all of this good stuff out. So here, this side will become 16x plus 4, and this side becomes x squared plus 4x plus 4. So I omitted showing you how to work all of this out because I'm going to assume that you're good on that. Okay, so now that we're here, now we have to take a look at what we actually have. Notice this is squared, so now that's telling me that I'm probably going to have to factor. So basically, once you get rid of the radicals, then you're just saying to yourself, okay, how can I actually finish this? So in this particular case, what I can do is factor, and so I'm going to go ahead and bring these two terms over to the other side. So this will be minus 16x and minus 4. So now I'm left with x squared minus 12x equals 0, because the 4 is actually dropped out. Now remember, you're not trying to, so this is, since this is squared, your goal here is to try to factor this. So you're not dividing everything by x, you actually need that so that you can see kind of everything that makes this up. So I get x times x minus 12, and so then in this case my two solutions here would be x equals 0 or x equals 12. So there are my two possible solutions. Oh, but wait, there's more, right? So now we have to actually check it. So let me clear myself a little space so that I can check. All right, and I'll just do my check right over here. Okay, so check this out. I plugged I plugged 0 in, and what I ended up getting was -1 equals 1. So what that tells me then is that 0 is not actually a solution type. So now I have to check the other one. So let me just get rid of all this and I'll try the other one. And so 12 actually works out, so there's my only solution. So as you can see, this is quite a bit of work. So I'm going to walk you through the next example just because I know it's a lot of steps. Okay, so first things first, like we said, I'll give you some prompts for where you should pause and try if you want to follow along here. So first things first, you want to have one radical isolated to each side, so we have that. And now you want to square both sides. And so when you square both sides, you can see here that you're going to have to FOIL this side. So what I want you to do is FOIL this side and then collect any like terms and then hit play when you're ready. Okay, so I'm going to have 3x plus 6 equals, so this, when I start FOILing this out, this becomes 4 plus 2 times the square root of 2x minus 4 plus 2 times the square root of 2x minus 4 plus 2x minus 4. So I didn't write out all of the multiplication, but there are the pieces to it. And then if I collect my like terms, so what I end up getting is 4 times the square root of 2x minus 4 plus 2x. So the 4's actually end up dropping out, right? So now what I want to do, so if you got to this point, so that's good, see if you have to correct anything. So now what you want to do is you want to isolate the radical. So how do we do that? So if I'm trying to just get this piece by itself, so remember you can't do anything with the 4, but you could subtract off the 2x and that will at least get what's left over for the radical isolated. So now I've got x plus 6 equals 4 times the square root of 2x minus 4. From here, you're going to square both sides again and then FOIL again and try to see if you can finish solving this. So hit play when you're ready. So try to FOIL out both sides and kind of see where you're at, and I'll see you in a moment. Okay, so I want to square this side and I want to square this side. So this side will be x squared plus 12x plus 36, and this side will be 16 times 2x minus 4. So I get x squared plus 12x plus 36 equals 32x minus 64. And so now at this point I can see that this is squared, so I'm probably going to have to factor this. So if you haven't finished the problem yet, go for it. So I want to subtract off the 32x and I want to add the 64. So let's see, what do I actually have now? So now I have x squared minus 20x plus 100 equals 0. So how does that factor? So then finally to factor this, so this is x minus 10 times x minus 10. So I actually just have one solution here. So I'm running out of room, but I'll write this. So my solution here would be x equals 10. And so let's see, I need to do a quick check of this. So let me clear a little space. So I want to check x equals 10. So I'll do that real quick right here. And so you can see from the check that that does indeed work. So now that we've gone through that example, I have this example here for you to try. So pause the video and then hit play when you think you're ready. Okay, so first things first, we're going to start by squaring both sides. So I'm going to square this side, I'm going to square this side, and so then I have to FOIL out this side. So let me write that out. So this will be just 3x plus 1, and this will be 4 plus 2 times the square root of 2x minus 2 plus 2 times the square root of 2x minus 2 plus 2x minus 2. So now let me collect my like terms. So as I look through this, it looks like I get 2 plus 2x plus 4 times the square root of 2x minus 2. And now I need to isolate the radical. So I'm going to subtract this 2x and I'm going to subtract this 2. So I get ultimately x minus 1 equals 4 times the square root of 2x minus 2. And now I can square both sides again. So I square each side. This side, if I FOIL it out, will be x squared minus 2x plus 1. And this side will be 16 times 2x minus 2. So now I have to distribute. So I've got x squared minus 2x plus 1 equals 32x minus 32. And so now I can go ahead and subtract this off so that I can hopefully factor this. So let's see, I'll subtract off the 32x. And I'll add this 32. So now I get x squared minus 34x plus 33 equals 0. So this will factor then as x minus 33 and x minus 1 equals 0. And so my two solutions here are 33 or 1. And in the interest of time, I'll just tell you that both of those solutions actually work, so I'm going to omit doing the check here. Okay, so that's basically the idea, but if you want to try more examples, I have these two. So remember, the key here is that you do have to isolate the radicals before you begin this. So if you want to try these, go for it. Otherwise, consider giving this video a like, and I'll see you next time. But otherwise, I'll go through these two, and that'll be it. Okay, so starting with this one, so like I said, you've got to have the radical isolated. So I actually want to subtract. I'm going to just subtract this one off to the other side so that I actually have the problem square root of 2x plus 4 equals 3 minus the square root of 1 minus 2x. And now I can square both sides. So this side will be 2x plus 4, and this side will be 9 minus 6 times the square root of x, times the square root of 1 minus 2x plus 1 minus 2x. So notice I kind of just jumped ahead to combining at least the two radicals here, so I'm trying to cut down a couple of steps. So this is what you should get. And then if I collect all my like terms on this side, so I get 2x plus 4 equals 10 minus 2x minus 6 times the square root of 1 minus 2x. So now I need to bring the 2x over and the 10 over so that I can isolate the radicals. Okay, and oops, I just realized I need to subtract 10 here. So this will now become 4x minus 6 equals negative 6 times the square root of 1 minus 2x. So notice here that everything is divisible by 2. So you can do this if everything is divisible by a certain number. This will just kind of make the next step a little bit simpler. So here's now what I have to actually FOIL out and square. So if I square both sides, so I square this and I square this, this will give me 4x squared minus 12x plus 9, and this gives me 9 times 1 minus 2x. Okay, so I'm running out of some room here, so I guess I'll continue up here. This is 4x squared minus 12x plus 9, and this is going to equal 9 minus 18x. So now I can subtract off the 9, and I can add the 18x. So I get 4x squared plus 6x equals 0. So now I can actually factor this out, so I'll factor out 2x. This leaves me with 2x plus 3 equals 0. So my two solutions here are x equals 0 and x equals negative 3 over 2. And once again, I know that those work, so I'm going to omit the check here, but those you would actually want to go back and check. Okay, so we've got one more of these. So once again, I'm going to go ahead and square both sides. And I'll just show you what that looks like. So this becomes 2x plus 4 equals 4 plus 4 times the square root of 2x plus 3 plus 2x plus 3. So I'll collect my like terms. So I've got 2x plus 4 equals 7 plus 2x plus 4 times the square root of 2x plus 3. So let's go ahead and isolate the radical. So I'll subtract off the 2x, and I'll subtract off the 7. So now I get that this equals negative 3 equals 4 times the square root of 2x plus 3. So now I'm going to once again square both sides. This time I don't have to FOIL. So this gives me 9 equals 16 times 2x plus 3. So this is 9 equals 32 plus 48. So I'll go ahead and I'll subtract off the 48 here. And so I get 32x equals negative 39. So when I divide both sides by 32, so this is, let's see, this is actually not divisible by anything, so I just get x equals negative 39 over 32. And so I will tell you that for this particular one, if you try to go and actually plug this in, it does not work, so you get no solution. You might have had a hint about that when you were at this step, but I just wanted to kind of show you what the whole example would look like. Okay, so that concludes this lesson. So if this was helpful to you, please consider giving this video a like, a comment, or a share, and I will see you guys next time. Good luck with your math.